In this presentation, we will cover hypothesis testing for means. We are interested in the parameter mu, which is somewhere on a real number line. We start gathering information. And once we have a large set of data, we summarize it with a sample mean. If the data's distribution is normal, then the sampling distribution is normal. However, if the data's distribution is unknown, the sample size must be large enough to invoke the central limit theorem. As the sample size increases, the sampling distribution approaches normality. The test statistic is given by the sample mean minus the population parameter over the standard error, which is the standard deviation divided by the square root of n. This is assuming the standard deviation is known. The standard deviation is what controls the pivot points, or the points of inflection in the probability distribution. If we have to estimate the standard deviation with the sample standard deviation, then freedom is lost and we have affected the points of inflection. In this example, we will discuss hypothesis testing for means when sigma is known. First, you will be given an initial amount of information: the sample size, the level of significance, the sample mean, standard deviation if known, and the hypothesized mean. The null hypothesis is that the mean is in fact equal to the hypothesized value of 35. Alternatively, as we have observed a sample mean of 30, we believe that it is either not equal to 35, or we could argue that it is less than. Less than is a stronger statement. Here the assumptions are satisfied. N is greater than or equal to 30, and the standard deviation is known. Therefore, the population's distribution need not be normal to invoke the central limit theorem. The test statistic is z. Looking up the test statistic on a chart, we can find the p-value. Comparing the test statistic to a critical statistic, or the p-value to the level of significance, we can make our decision. At the 5% level of significance, there is sufficient evidence to reject the null hypothesis. Consider the following example when sigma is unknown and the sample size is less than 30. Then we must assume the data's distribution is normal to proceed. Otherwise, we cannot invoke the central limit theorem, and we should not argue. Assuming the data is normal, let's proceed. The null hypothesis is that the mean is 35. Alternatively, we believe it is either not equal to 35, or because we have observed 30, we can argue less than. This time the test statistic is t. If we use software to determine the p-value, we can compare the test statistic to a critical statistic, or the p-value to an alpha value. In this example, at the 5% level of significance, there is insufficient evidence to reject the null hypothesis.